Yes, it is.
Okay, so it was about the referential integrity that we were talking about before the break, right?
Yes.
So we need to understand exactly how the referential integrity is created. So for that, here we will create another table, create table. I want that table also to be going in the same schema. So here I say companies, company dot MPS for employees, parenthesis, what fields we discussed, employee number, int. I want this to have auto numbering in sequence 1, 2, 3, 4, and so on. And I want this to be primary key as well. So first of all, I say it is int, then followed by primary key constraint, followed by identity definition. In bracket, I say 1 is the start number and increments by 1. Then I say name is the next field, is of type and varchar 50, not null. And then we had department number, integer. It has to have the same type as that of our original table. Name may or may not be same, that's okay. And then here itself, I could say foreign key, references, the parent table departments. In fact, it will be company.departments. And within parentheses, the field name from the departments table, which needs to be referenced. Okay, that is one of the way. Select this.
Sir, so this department number, the second one should be the same as the mentioned one in the department's table, right?
Departments table, yes, because this is a column name of the departments table, which we are looking to refer. Here on the left hand side, I mean, at the beginning of this line 53, this name can be anything because this is the field which we are defining currently in employees table. Understand?
Yes, sir. Yeah.
Let's select this. Maybe I should put go, select, and execute. Done. Now the effect of this we'll see here. So one is insert operation that you can try with insert statement, as we have already seen that. Maybe this time we can see how designer can help us. Here I refresh the tables. I do see employees table. I right click this and go for the option edit top 200 rows. Employee number is auto number, right? So we don't need to give any input there. It's read only, in fact. I say name is James. Department number. What all department numbers exist in our departments table?
In 2030.
10, 20, and 30. We will just confirm that. Ten, 20, and 30. So here, if I put 40, what would happen? What do you what do you guess? Will it accept?
Take it.
I click on the next row. It says it's not committed. Reason: foreign key constraint violated. Okay. I say it's department 10. Taken. My employee number is 2. It should have been 1, right?
It is
Simply,
one.
it's not 1 because I attempted with a wrong department number earlier, where it already generated employee number 1,
Okay.
and that record got failed, right? So next time when I save, it will generate the next number. Like here, I'll go with the normal entry. So let's say it is John, department number 20, which belongs to the table. I put one more entry, Jerry. I keep it null. That is valid entry. So 2, 3, 4, I see there. So I say Jimmy. And again, I say department number is 100. I make a mistake. And then I try to move to the next row. Again, the error. And then I correct this to department 10. See, it skipped 5. Understood?
Yes, sir.
So null is accepted, 10 is accepted, 20 is accepted. Here, if I try to modify an existing record, say instead of 20, I make it 200. Let's see if it takes it. Doesn't. If I say 30, that's fine. Null replaced with 20, that's fine. So in any point in time, the values taken over here would be either null or the values which are there in the referenced table or parent table. Understood?
Yes.
So, excuse me, sir. Why did it skip 5? I joined a bit late, so I skipped
Uh,
that part maybe.
did you saw it skipped 1 also?
No, sir. That's the issue. I didn't.
See, I'll show you. I go for another entry. Okay. I put some non-existing department number. Error. I replace this with another non-existing number. I click on another row. Still there is an error. And then I go back to something which exists, or I make it null. It does accept. See here, it skipped 8 and 7 both, because there were 2 attempts with 2 wrong values, correct?
Yes, sir. Got it.
So it skipped those 2 numbers. 7 was a attempt with incorrect value. 8 was another attempt with incorrect value. Both got skipped. It will keep on generating numbers, whether the record is successfully saved or not. Do you get it? Like if there is invoicing system, if there is an invoice generated with errors, even if we cancel it, that number is not released. That invoice just says I'm missing. So we assume that it may be a cancelled invoice, right? We cannot generate another invoice with the same number, even if the previous one is cancelled. We get it?
Yes, sir.
So I hope this everyone understands the referential integrity as well. Yes. I say drop table company dot PMPS and go. Remove this and I recreate this table, this time without foreign key constraint. Almost everything same, just this part I am going to avoid. Fine. I recreate the table. In this case, there is no referential integrity. So what would happen? If I try to give any input for the department number where that department number doesn't exist in department table, it will accept that also. Yes or no? Tell me quickly. Yes or no?
Yes.
Reason? There is no constraint that is checking whether the number being entered belongs to the department table, department number or not. Am I right?
Yes.
How do I add that constraint? Now, after creating a table. Again, it is alter table statement. Alter table, table name. What I want to do, add constraint, constraint name. So can I say it is ref underscore or maybe fk underscore department number? And then foreign key references, the same thing what we added at the column level earlier. The difference between two approaches is, in fact, there are two differences. One is, in first case, we added constraint inline along with the table creation. In uh, second case, we are adding the constraint after getting the table created. So that's first difference. The second difference is when you apply the constraint directly on the column, it is called as column level constraint or field level constraint. Whereas when you do it with alter table, it is always going to be a table level constraint. Understood? When you say add
Yes.
constraint, it is table level constraint. Let's say go and oh yeah, I missed something. Foreign key. In this case, I need to specify the current table column name also on which it is applying. So here I have to say department number. Okay, because here by default it doesn't know which column it is supposed to apply it. So I'm applying department number column with the foreign key reference. That reference is company departments department number. And now the effect is going to be same. You can once again go and say edit and try giving the inputs. See if it is accepting the incorrect department numbers or non-existing department numbers or not. It should accept the ones which are there in departments table or the null value. Anything other than these two sets is not permitted. Just check and confirm. I'll wait for 2 minutes.
So it's showing foreign key references invalid table company dot debts.
Can you share your screen?
Yes, wait. One second. Can you see?
Yes, just that I'm getting some echo.
Now is it okay?
Yeah, that's good. Can you zoom the code a bit?
Yes.
It should not be giving any error. Just select and click on
Yeah.
execute. Okay, invalid table company dot departments. Are you sure you have not dropped the company departments table?
Oh, I dropped this table. I have never dropped the departments table.
Okay, no worries. Let's verify that. Right click on tables in the Object Explorer and refresh. Expand. Yeah, your
Wait.
department table got dropped. That's why you are getting the error. Everything
Achha.
else is okay.
All right. I'll create it. Okay.
Yes, yes. Okay, so other guys, did you check? Is it working?
Yes, sir, it's working.
Same way, right? Like earlier?
Yeah, commands completely same.
Okay. So that's all about the data integrity part. There are many combinations, in fact, that you can go through. So I'll share some links with you in order to explore further. Now let's move on to the last part of the day where we are going to talk about the indexes. So in fact, I've got a nice video on the same, which is not very big, just 14-15 minutes of video, and is explaining overall working of the index, how it actually works at the system level. So that will be actually nice to understand, because once we understand that, creating and using indexes becomes pretty straightforward. Make sense? I was just
Yes, sir.
going through the things and I just came across this video. I found it nice. I wanted to share that with you. So just give me a minute. I'll share that on my screen. Just check if the screen is visible first of all.
Yes, sir, it is.
Okay. Let me play it and confirm if the sound is audible as well. I'll play for 5 seconds. Just confirm the sound is audible. Then I'll continue.
Hey guys,
Audible?
It's audible.
Okay. So I'll just proceed.
Yes, sir.
Venkat, and in this video, we'll discuss how indexes actually work and help improve the performance of our SQL queries. We'll discuss how both the index types work, clustered and non-clustered. If you're new to indexes, we have already covered all the basics you need in this SQL Server tutorial for beginners course. Please check out the videos from parts 35 to 38. I'll include the link in the description of this video. Now, consider this employees table. Employee ID is the primary key. So by default, a clustered index on the employee ID column is created. This means employee data is sorted by employee ID column and physically stored in a series of data pages in a tree-like structure that looks like the following. The nodes at the bottom of the tree are called data pages or leaf nodes and contains the actual data rows, in our case, employee rows. These employee rows are sorted by employee ID column because employee ID is the primary key, and by default, a clustered index on this column is created. For our example, let's say in this employees table, we have 1200 rows, and let's assume in each data page we have 200 rows. So in the first data page, we have 1 to 200 rows. In the second, 201 to 400. In the third, 401 to 600, so on and so forth. The node at the top of the tree is called root node. The nodes between the root node and the leaf nodes are called intermediate levels. The root and the intermediate level nodes contain index rows. Each index row contains a key value, in our case, employee ID, and a pointer to either an intermediate level page in the B tree or a data row in the leaf node. So this tree-like structure has a series of pointers that helps the query engine find data quickly. For example, let's say we want to find employee row with employee ID 1120. So the database engine starts at the root node and it picks the index node on the right because the database engine knows it is this node that contains employee IDs from 801 to 1200. From there, it picks the leaf node that is present on the extreme right because employee data rows from 1001 to 1200 are present in this leaf node. The data rows in the leaf node are sorted by employee ID. So it's easy for the database engine to find the employee row with ID equals 1120. Notice, in just 3 operations, SQL Server is able to find the data we are looking for. It's making use of the clustered index we have on the table. Let's look at this in action. This piece of SQL script at the top creates employees table with these 4 columns: ID, name, email, and department. First, let's create the table. This second block of code here inserts test data into employees table. Let's actually execute the script. It's going to take a few seconds to complete. And that's because if you take a look at this code, notice we're using while loop to insert 1 million rows into this table. And if we click on the messages tab, in a few seconds, we should see a message saying 100,000 rows inserted. That's because for every 100,000 rows that we insert, we are logging the message. Let's give it a few seconds to complete. There we go. All the 1 million rows are inserted. Now let's execute this select query. We are trying to find employee whose ID is 932,000. And before we execute this query, click on this icon right here, which includes the actual execution plan. You can also use the keyboard shortcut Control M. There we go. We got the one row that we expected. And when I click on the execution plan and when I hover over this, notice the operation is clustered index seek, meaning the database engine is using the clustered index on the employee ID column to find the employee row we want. Number of rows read is 1. Actual number of rows for all executions is also 1. Now, number of rows read is the number of rows SQL Server has to read to produce the query result. In our case, employee ID is unique, so we expect 1 row, and that is represented by actual number of rows for all executions. With the help of the index, SQL Server is able to directly read that one specific employee row we want. Hence, both number of rows read and actual number of rows for all executions is 1. So the point is, if there are thousands or even millions of records, SQL Server can easily and quickly find the data we are looking for, provided there is an index that can help the query find data. Now, we have a clustered index on the employee ID column. So when we search by employee ID, SQL Server can easily and quickly find the data we are looking for. But what if we search by employee name? At the moment, there is no index on the name column. So there is no easy way for SQL Server to find the data we are looking for. SQL Server has to read every record in the table, which is extremely inefficient from performance standpoint. Let's actually look at this in action. Here is the query. We are trying to find the employee by name. Let's execute it. There we go. We have the one row that we expected. And I click on the execution plan and hover over this. Notice the operation is clustered index scan. Since there is no proper index to help this query, the database engine has no other choice than to read every record in the table. This is exactly the reason why number of rows read is 1 million. That is every row in the table. And if you take a look at actual number of rows for all executions, the value is 1. How many rows are we expecting in the result? Well, only one row, because there is only one employee whose name is ABC 932,000. So to produce this one row as the result, SQL Server has to read all the 1 million rows from the table because there is no index to help this query. This is called index scan, and in general, index scans are bad for performance. This is when we create a non-clustered index on the name column. Actually, SQL Server is helping us here. Notice it's actually telling us there is a missing index. To improve the performance of this select query, it's asking us to create a non-clustered index on the name column. Why on the name column? Well, that's because we are looking up employees by name. So let's actually right click on this and select this option, missing index details. We actually have the required code here to create non-clustered index. Let's uncomment this, create non-clustered index. We are creating on the name column, and let's give this index a name, ix for index. We are creating it on the employees table and on the name column. Let's execute this. Now let's execute that same select query again. Click on the execution plan tab, and we have several steps here. We'll discuss execution plans in detail in our upcoming videos. For now, just understand we read the execution plans from right to left and top to bottom. So we start here, and when I hover over this, notice now the operation is index seek on the non-clustered index. Before we understand this execution plan, let's first understand how non-clustered index is stored in the database. In a non-clustered index, we do not have table data. We have key values and row locators. We created a non-clustered index on the name column. So the key values, in this case, employee names, are sorted and stored in alphabetical order. The row locators that are present at the bottom of the tree contain employee names and cluster key of the row. In our example, employee ID is the cluster key. Why? Because employee ID is the primary key. By default, it is the cluster key. Now, if we look at one of the row locators, notice the names of the employees are sorted in alphabetical order, and we also have their respective employee ID. Now, if you remember, on the employee ID, we have the clustered index. Now, when we search employee by name, both these indexes, non-clustered index on the name column and clustered index on the employee ID column, are going to work together to find the employee that we are looking for. Let's look at the steps involved. First, SQL Server uses the non-clustered index on the name column to quickly find this employee entry in the index. In a non-clustered index, along with the employee name, we also have the cluster key. In our case, it's employee ID. The database engine knows there is clustered index on employee ID. So this clustered index is then used to find the respective employee record. Now, let's relate these steps to the execution plan that we have in SQL Server Management Studio. Remember, we read the execution plan from right to left and top to bottom. So we start on the top right here. Notice the first step is index seek on the non-clustered index. On the name column, we have non-clustered index, and SQL Server is using it to find an entry for this employee in the index. And remember, in the index, along with the employee name, we also have employee ID, which is the primary key. Next, this primary key is used to find an entry in the clustered index. That's why we have the operation here as key lookup clustered. The value from the clustered index, in our case employee ID, is then used in an inner join with the employees table to retrieve the respective employee's record. If you're new to these execution plans and wondering why this nested loop or inner join is required, we'll discuss these execution plans in detail in our upcoming videos. Now, on this slide, I have estimated subtree cost with and without index. So for this query, select star from employees where name equals whatever name we supply. Estimated subtree cost without index is 11 point something. With index, it is 0.006. Just imagine the impact it can have on performance if we don't have index on the name column. If you're wondering, how did I get these statistics? Well, in SQL Server Management Studio, on the Execution Plan tab, if you hover over the select operation, you get the total estimated subtree cost for all these operations. In our upcoming videos in this series, we'll discuss SQL Server execution plans in detail with examples. That's it in this video. Thank you for listening.
Okay, so few questions over here, just to make sure you understood the overall concept. There are okay. How many types of indexes are there in SQL?
Clustered and non-clustered.
Yeah, clustered and non-clustered index.
That's right. So two types of indexes, clustered and non-clustered. And while creating the index, what are the statements that we use for both the types of indexes? Create clustered index name on table within parenthesis column is the syntax for or statement for clustered index. So suppose in employee table, you are looking to create clustered index on ID. Usually that's not required because when you create a primary key, automatically the clustered index is created. Unique clustered index is created on that primary key column. Do you understand? But in some case, if you have not created the primary key, but you want index, you can create one with this create clustered index. Let's say you name it as IX employee on employee, within parenthesis you put employee number, and it will create the clustered index. If you want to make the values in that particular column unique, you can say create unique clustered index. Index name on table name within parenthesis field name. Do you understand?
Yes, sir. So, but it would be better if you can show us once.
We'll see that in a short while. Okay, so just try to memorize this as of now. Now with non-clustered index, what changes? Just the keyword clustered is replaced with non-clustered. Everything else remains the same. So technically creating index is not a big challenge. Statement is pretty straightforward. Create. Optionally, you can use unique keyword followed by clustered or non-clustered, followed by the keyword index, followed by the keyword on, followed by the table name, and then within parenthesis the field name. Exactly same syntax for both of the type of indexes. Understood?
Yes, sir.
Now
So I have a question.
Yeah,
So for
Siddharth.
example, in clustered index, the key value
Yes.
should be unique, right? There should be a key value.
Yes, correct.
But in non-clustered, we can have more than one, I guess, indexes with the same key value. So what does that, how does the non-clustered index differentiate between those? Does it take into consideration some other column as well?
Yes, it does. In that case, it falls back to the clustered index. As in the video also, it was shown that first it used the non-clustered index, and then in the third step, it went to the clustered index to find out the actual employee, right? So there it will do the comparison and will pick up the right value. Understood?
Okay. Yes, sir.
So clustered index is going to be very, very helpful in this case. And not only that, if you have the other non-clustered indexes also created in the table on other columns, they can also take part depending on how you have created your query. Is your query using that particular field in the criteria section, I mean after where clause or having clause, on which the other non-clustered index is created or not? Clustered index is going to be used always, but non-clustered indexes will be used when you are having that field on which the non-clustered index is created included in where or having clause. Otherwise, that non-clustered index will be ignored. Clear, Siddhant?
Yes, sir.
Okay.
Sir, I have
Now,
one doubt.
yes,
Yeah. So, like when primary keys are made, then clustered index is already applied, right?
automatically created. Yes,
Yeah. So, like, suppose we have a primary key, but the
yes,
sequencing is like not properly done. So, like, it goes from 1 to 100, then next it starts from like suppose 1000 to 1200, right? It's not sequenced properly. Then
okay,
when the tree is going to be made, like the tree's
yes,
branches,
yes,
then in the example we saw that if it was sequenced, then we could just do 100 to 400, then 400, then
right.
it could be expanded. But in our case, that the sequence is not proper, right? So how will it work? Like, will it affect
See,
efficiency
it's
of our?
in fact your question itself has got the answer. Uh, if you have the situation like 1 to 400, you have the sequence maintained, and then you have 1000 to 1200 or 1300, right? That's what you are saying?
Yeah, but it could be like anything. I'm not just
Yeah.
if
So let's take this itself for the example. It will be easy for understanding. Okay. So what it will do is it will generate the tree structure in that way only. 1 to 400 is here, and 1000 to 1300 is the next node.
okay,
Right. The
yeah,
nodes have their boundaries already defined. The node says 1 to 200, and then 200 to 400, and then maybe 1000 to 1200, and then 1200 to 1300. The nodes will have their boundaries defined, right?
okay,
So
yeah. So
when
the data,
exactly, so when you do search for a value which doesn't exist, what it will do, it will say it doesn't exist, because
yeah,
the value that you are giving in the where clause simply is not belonging to any of the node of that particular tree. Correct?
okay,
If
yeah,
there is
I got
no entry for that value in the tree, that means it doesn't exist. I don't need to keep checking whether it is there in this node or that leaf node or something. Simply it doesn't exist. Understood?
yeah,
So
got it.
to make this simplified, let's understand what at the very basic level the indexes are. Everyone has used some textbook, right, for a lot of years in your schools and then college, correct? Each
Yes, sir.
book, each textbook starts with the index. Yes or no?
Yes, sir.
What is the purpose of that index? First of all, tell me. And what it
Easy
contains.
navigation and searching of
Easy
topics.
navigation. It contains the major topic names and then the page numbers. Am I right?
Yes, sir.
You just find out whether that particular topic is there in that index or not. If yes, in front of it, you find the page number and you go to that page number easily. Instead of reading each and every page of the book, this is something which helps you reach there quickly. Am I right? And especially if you are using a digital version, you can just jump to the page number directly. The reader applications mostly provide you the user interface to jump to the specific page anytime. Am I right? Like PDF reader itself, if you see, there is a page number option on the top. You put the page number and you are automatically taken there. Yes or no?
Yep.
Right. So that's the exactly same concept over here when it comes to index, whether it is clustered or non-clustered in both cases. How they work that we have seen. Syntax I'll just show you in a short while. Another important thing to understand over here is like what is the difference between the two types of indexes, clustered and non-clustered. Clustered are actually storing the values, right? The rows, row identifiers, whereas non-clustered are key value pairs only. Now, one more difference, which is the major difference, is you can have only one clustered index per table. How many clustered indexes I said per table? Just one. Whereas you can have 32 non-clustered indexes in one table. How many I said?
32.
32. Okay. Now, why clustered index can be only one?
Because it's based on the primary key, I guess.
Primary key, yes. Most of the time it will be based on primary key or unique key column. So that's right. And then the kind of tree clustered index builds is possible only on one field at a time, right?
Yes, sequentially increasing, I guess. So
Exactly. So it can have only one tree like that, correct? Whereas
Yep.
key value pairs can be generated in any combination. Am I right? Different
Yep.
trees can exist together. So that's why non-clustered index more than one can be created up to a maximum of 32. That's the current limit.
So
Right. So that
I
is a
have,
major difference.
so
Yes,
I
you're
have,
done.
yeah. So I was thinking, so for example, in non-clustered index, right, we have nodes and we have subnodes, right? So
Correct.
what is the optimum number of subnodes that a non-clustered index tree should have? For example, is it a red-black tree? That is generally the convention if there are two subnodes in a tree. So what do we actually look at? What's the optimum number of nodes that a subnodes has in order to facilitate a faster search?
See, usually most of the time the systems follow that B tree kind of concept over here. Right. So you will have one node which will have two subnodes which will further have their own subnodes. So levels may vary, but each node will have two subnodes at the top. Understood?
Yep, got it.
If you look at the algorithms, the search algorithms you might have played around with in C or C++ language while working with arrays precisely or collections, you might have noticed the most efficient search algorithm was binary search algorithm only,
Yeah.
right? And this is applicable precisely for almost any data type because at the end, whatever is the type of the data, it is represented as numbers only. Am I right? Because computer knows only numbers,
Yes.
right? So that's where the binary search becomes important, and that says that the tree that is created is B tree, binary tree.
So I guess in that way, it's not a red-black tree because a red-black tree, each
Correct.
node will have two nodes. It's a M-way tree, I guess.
Correct.
Okay.
Understand? So overall way of working you have understood. Yes. There are few more things we have to take care of. If I create a clustered index and then I create non-clustered index, there is no problem. But if I have created a table without any key and define one or more non-clustered indexes already, and then I am creating a clustered index, all of my non-clustered indexes will be automatically dropped. Why is it so? One point you might have noticed in the video, this guy said clustered index actually is something which modifies the sequence of the records that are stored on the physical storage. And that is possible if and only if there is no other index available. So when you create a clustered index, all non-clustered indexes are dropped. That's by design. And then the clustered index does its job. It just arranges the data, sorts the data, stores it in that sequence in the physical storage, and then builds the tree, index tree. And then later on, you can create as many non-clustered indexes as you want, up to a maximum of 32, right? Remember this rule. Never ever create non-clustered index before having a clustered index in place. Clustered index should be the first index to be created. Is it clear?
Yes, sir.
Okay, let me share the link of this video first of all. It will be helpful. Anytime you can actually go through it.
And non-clustered. If you're new to indexes, we have already covered all the basics you need in this SQL Server tutorial for beginners course. Please check out the videos from parts 35.
Just check your chat box. If you have received the link,
Yes, sir, received.
just bookmark it into your browser. It will be helpful in order to understand exactly how the indexes work, right? Okay, now it's all about understanding exactly the syntax for the indexes. So here, if you see departments table, if you expand indexes, I do see there are two indexes already created for me. Clustered on department number, and DNAME has got unique non-clustered index created. Okay, now here let me say right click on one of the index, and there I select script index as create to new query editor window. It automatically shows me exactly what statement is required. These are all additional options. These are not mandatory ones. So if you don't provide them, the default values, what are there, are going to be used. So practically, this is what you have. It will rather start with create. If the table is getting created, I mean, why table came in here, why not index, is because this index was built as the part of the table creation. There we said no, add constraint primary key. I mean, employee number or department number in primary key, we said directly. That's why the table alter or table create statement comes in. Look at this one also. Okay, this was added as a non-clustered index. No worries, we will just get it added explicitly then. So here I say delete this, and we'll rebuild this index. It was on name column in employee table, right?
Yes, sir.
So we go to the end of our script, and here I say create unique, as I want a unique index to be created. What type of index I want? Non-clustered. There is one clustered index already in my employees table. I can say create unique non-clustered index on. It was department table, I believe here.
Name of the index then on, right?
Yeah, correct. The index name will come first. So I say ix underscore dname on company dot departments, and then here I say dname, and then go. It says command completed successfully. The new index must have been built. So here I go to Object Explorer, Departments table, indexes. I right click on indexes option and say refresh. Do you see the indexes created here? Now the effect of this you can find if and only if you have millions of rows. For 10, 20 rows or 2 rows or 5 rows, it won't make much difference, because even if I read the whole table, it won't take much time. There are only few entries. In fact, with less amount of data, it's not a good idea to build the index basically, because I will be wasting time in reading index first and then reaching to the record. When I have huge number of records, that's where index helps me. Got my point? So you can actually try out the example which is there in the video for this. Syntax, it's this only. If it is clustered index required, just one change required in this. Understand?
Yes, sir.
Okay, so exact same example which is there in video. Probably you can try that, and let me check if there is a link or there is some script which has been pasted that actually shows us this script also, what has been used in the example. So let us go to this video.
With DigitalOcean managed MongoDB, you don't have to worry about database administration. Provision a MongoDB cluster.
Okay, so I believe this is the site where you will find the theoretical concept also of this. And here you have the script also. So let me share this link into the chat box as well. It will be easy for you to try, right? Just bookmark this link as well. So what they are doing, if you see, creating a table called as employee. This you can understand. We have used this. Am I right?
Yes.
Yes, sir.
Then what this no count on does, in the messages window, you see 2 rows affected, 1 row affected, 0 rows affected. Am I right? In some cases, I may not want those messages to be created. So that is where set no count on is required. And before your script ends, actually, you should say set no count off as well. Now, what does this declare? This is a T-SQL statement. Declare at counter int equals to 1. So basically here we are declaring an integer variable named as counter. At represents it's a local variable. Initialize to the value of 1. Now this structure you can understand, right? While counter at counter less than equal to 1 million. what we want to iterate this script 1 million times, starting from 1 to 1 million, correct?
Yes, sir.
What we want to repeat is there wrapped in between begin and end. Three variables being declared here: name, email, department, whose value is getting generated here: ABC, department, and then we are appending the value of counter just to generate the dummy or the sample data. The second one is email. So here at prag imtech.com also is getting appended. This can be changed to whatever you want, maybe providence.com or something like that. And then here goes the insert statement. This insert statement is going to run 1 million times. Every time we are incrementing the counter. And we are also checking if counter mod 1 lakh or 100,000 returns 0. That means every 100,000 rows, we are printing the message that displays us the counter value followed by rows inserted. You might have noticed in the video, right? 100,000 rows inserted, 200,000 rows inserted, till 900,000 rows inserted, ended up with 1 million rows inserted and finished. Yes?
Yes, sir.
And then here he used some tools like the execution plan where you have that button. Let me show you that. This is where the button is. In fact, here it is. Include an actual execution plan. If I go with the query like select star from company.departments where department number is equal to 20. I want to see how the search is happening. I just enable this button, include an actual execution plan, and then I click on execute. So when execution plan button is enabled, you see there is one more tab coming in, execution plan. There it shows clustered index seek. This is exactly the same information we saw in video, right? Number of rows read 1, actual number of rows for all executions 1. That is the best scenario. We are pinpointing the row and reading it. Now let me change this with where location equal to Chennai. Include execution plan is already on. I say execute. Result is there. I go to execution plan. Here it shows me clustered index scan. And there, if I see the details, unfortunately, it says number of rows read as 3. All the records in my table have been processed, and then I got just 1 row. Is it a good situation?
No.
Any time when you have index scan or table scan, that is not considered to be good. It has to be index seek. And the number of rows read should be as smaller as possible. Understood? I will not say it has to be 1 only always. Sometimes your criteria may say that, okay, there are 2 or 3 rows matching the criteria, out of which 1 need to be selected. So out of say 3 million rows, if it shows the count as 30 or 3, that's okay. But if it shows the count of all the rows which are there in the table or in the index, that is a problem. Right now, I just have 3 rows. What if I have 3 million rows? Don't you think it will take a lot of time to read 3 million rows? And especially if I'm not having database on my local machine, but the database is located somewhere in US, some US server I'm connected to. Don't you think it will take time?
Yes, sir.
Understood the importance of this execution plan. If you don't want to run the query, but you want to see the plan, the estimated plan, you can actually go with this display estimated execution plan also. There also it gives you the idea. It may not be accurate because it may not have actually processed all the data, but still it is near to accurate. These are the tools which will help you fine tune your queries, fine tune your indexes, fine tune your database so that they keep on performing good always. Usually this task is done by the database administrator, but yeah, as a developer, if you are aware of these things, you can actually suggest the database administrator that I'm having this query which is performing badly. These are the parameters I'm getting. Snapshots, if you share with database admin, you will get your solution more quickly. And database admin will be happy to help you out because half of the job you might have already done by that time. Make sense? Ultimately, client is more interested in getting quick solution. Client is never going to be interested in who did the job. Yes or no?
Yeah.
Yes.
Okay, so just go through this video, try out the example which is there on this page as well. Try to understand this execution plan concept, both the estimation and the actual execution plan, and basically try to understand exactly how the indexing is working, right? So performance tuning is something which you will get to know better from here. Got it?
Yes.
Right. So this article is almost the same thing what we have. In fact, based on which the video has been built. The same guy has created this article who has presented in that YouTube video. Here is the link for that YouTube video also. It's vice versa. Okay, and in fact, if you go to the SQL Server tutorial for beginners, you will find even more detailed inputs on all goods and bads of SQL Server. You can keep this link also bookmarked. Wherever available, the YouTube links are also already being shared by this site. It's a good one actually. Yes?
Yes.
Right. So many of the things we have already discussed, but then there are many other things. As I said, there will be some self-study also required. So this actually is having almost 150 different slides. That means 150 different sessions are there on different topics. It is much more detailed and will help you understand all the basic information about SQL Server, and that too in very much of detail, deep dive, like joins and subqueries. How do we work with them? How do we work with different select statements, like where I'm using the where clause, group by, having, order by, right? Different types of joins, null coalescing, then the functions which are already provided by SQL Server, like string functions, date functions, conversion functions, some arithmetic functions. A lot of stuff is there. So whenever you get time, just go through each of these sessions one by one. Got it?
Yes, sir.
Okay, so that is it for today's session. We'll meet tomorrow, same time, 9:30 a.m. And tomorrow we are actually going to begin with .NET.
I have one
Okay?
doubt,
Yes, Urmila.
small one.
Yeah.
So referential integrity. So we did the example of the constraint of foreign key, but
Yes.
I think I missed the idea of it. If you could just briefly explain it again.
Yeah. So I give you a different example altogether. Okay, you have attempted the board exams a few years back, right?
Yeah.
What is the process? How it all starts?
To
Your
fill a
schooling is
form.
happening, your sessions
Yeah.
are happening, and maybe 2 to 3 months before the actual exam schedule comes in, probably you need to fill up the forms. Am I right?
Yeah.
School distributes the forms which you have to fill up with all your details and everything, and based on which your hall ticket and all that is issued, correct?
Yeah.
Now suppose that is an online form
Okay.
and the link is shared with you guys. Somehow you forward that link to someone else outside the school also. The link will be accessible to anyone, am I right?
Yeah.
Now tell me, someone who is not actually the part of the school,
Mm-hmm.
his form, his or her form, should it be accepted?
No.
There will be some documents that need to be uploaded there, right?
Yeah.
There must be some roll number of the school also that needs to be added, and then the iCard and all, correct?
Mm-hmm.
Don't you think the system should actually go and check whether this roll number actually exists within my admission database or not?
Oh, right. Yeah.
So the table which I would be updating the data into is exam enrollment, correct?
Yeah.
But the roll number which I am giving input over here has to be validated or cross-checked within a different table. Which
Students.
table? The
Students.
admissions table,
Yeah. Admission.
right?
Yeah.
What it means? I am referring to a different table, different field, correct?
Mm-hmm. Sir, so isn't it the same as domain integrity? Because in that
You
also
are
we are
right. You are right.
actually.
But with domain integrity, the thing is your list of the values that needs to be cross-checked is predefined, hard-coded.
Oh,
In
okay.
this case, what is happening? Your list of values is not predefined or hard-coded. It is dynamic. It is being referred from within a table whose data can keep on changing.
Okay.
So that's where it becomes different. You are not manually giving values. You are saying refer that table. Whatever is there, work according to them.
All right. Okay.
So because you are referring to a table, it is having a different name called as referential integrity. So if you
Oh.
break it down, it does the same job as domain integrity. So you are right.
Hmm.
Okay. But it is doing something additional there. That's why a different name.
All right. All right. Okay. Clear. Thank you.
I hope this is clear to all.
Yes, sir.
Okay, then that's it for the day. And it's good that all the setup that we require for next 5 days also has been done today itself, so that tomorrow onwards we can focus entirely on the session, right?
Yes.
Yes. Yes.
So today you can just focus on this page which I've kept open on my browser, which is visible on screen, right? Just bookmark it, just go through it. uh, .NET framework things we will be anyways discussing right from scratch tomorrow, right? And I'll keep on sharing such kind of links with you for additional reading and additional practice. That anyways is going to be required, because the kind of plan that we have for these 6 days, usually it is delivered in almost 1 month. So when I say 1 month, it is like each and every bit is discussed within the session itself. Now, here the purpose of this training is not to go through the deep dive of each and every topic, but to understand how application is developed at the end, right? Because whatever we learn in deep dive session may not be actually required in specific project that you are going to be put in. So that way, sometimes it is wastage of time. So overall design of this program is basically learn the key things and learn the other things in detail, in depth, while actually working on the projects. on-job learning kind of thing they have planned. Your managers have planned. Understood?
Yeah.
So you become productive more quickly, no? That way. Little bit of research will be required additionally, and maybe instead of 6 hours, you might take 8 hours or 10 hours for that particular job. But that is how you are going to be learning more things, as you will be learning directly on the live project. Correct?
Yeah.
Okay, so tomorrow 9:30 a.m. we'll be starting with .NET Framework. I hope everyone enjoyed the session today.
Yes. Thank you so much.
Yes, sir.
Thank you so much.
Thank you, Saket.
Bye bye. Bye bye. See you tomorrow.
Thank you, sir.
Bye.
Thank you, sir.